Hey, what's up? It's Jake from Nimbus DevOps, and we're going to finish this section by going over saving data to a database. So we're going to work with an in-memory database, which will make things simpler for us. So there's a couple ways to do this, and you can explore your own ways to do it, but I'll just give you a couple. Let's talk about a relational database. So it's a database that allows you to save data following the relational model, which is very old. It's been around forever. You got tables, rows, records, tuples, each of which represent an entry in the table. A table has columns known as attributes, and they all represent an attribute of the record. Each record is identified through a unique key, more commonly known as a primary key, which is the union of one or more columns in the table. And to give you an example, just imagine a table called users, and you have a columns called ID, username, password, name, last name, stuff like that. So a table would be a perfect way to contain the users of your system, and each row would represent a different user, kind of like Microsoft Excel. So a row with the values like 3 Jake, some awesome password, and then Jake Furlong would be the user data in my system. That would give you my ID. It would give you my username, my password, my first name, my last name. The reason why it's called a relational database is because you can establish relationships between the tables. So, for example, if I added a table called phone numbers to this database, I could insert a phone number into it and then a relationship between the phone number and which user it belongs to on the users table. So in order to query a relational database, you need a special language. The most common language is SQL, which is the structured query language, and it's born out of something called relational algebra, which is amazing, and a family of algebra used to model data stored according to the relational model and perform queries on it. Most common operations involve filtering, joining tables, aggregating results, stuff like that. Things you would do in Excel. It's just stuff you would do in a database. So I'll give you an example like imagine you queried the imaginary database and be like, get all the users whose usernames start with the letter M who have like one phone number. In that query, you're asking for a subset of the columns in the user table. You're filtering on the users by taking, people whose name starts with an M, and then going even further and saying, and they have to have at least one phone number. So every database comes with its own like flavor of SQL, and all respect the standard to some extent, but none like really fully do. So they're all different from one another in some respects. And I spent years as a DBA, so I can tell you that um, everybody uses Postgres and MariaDB and stuff, but I've done Oracle and HANA and Sybase and a bunch of other strange stuff, and I mean they're all different, right? Um, if our app contains SQL code, it's quite likely that if you decided to use a different database or even a different version of the same engine, you'd find the SQL code probably needs to be changed. And that can be super painful, especially since SQL queries can get very complicated very quickly. So in order to alleviate this, we've created code that maps objects of a programming language to tables on a relational database. And not surprisingly, the name of it is the Object Relational Mapping, or ORM. So you'll see ORM models, and that is exactly what that is. So when you're doing app development today, you'd normally start interacting with the database using an ORM. And if you find yourself in a situation where you can't perform a query you need to through the ORM, you'd have to resort to using SQL directly. So it's a fairly good compromise having no SQL at all and using no ORM, which ultimately means specializing your code that interacts with the database with, the disadvantages that I just mentioned. So right now we're going to go over an example that leverages something called Sql Alchemy, which is one of the most popular third-party Python ORMs. So we'll have to do a pip install into the virtual environment for this chapter of this, or module, or whatever you want to call it, of this stuff that we're doing. And we're going to define two models, a person and an address, each of which maps to a table. And then we're going to populate the database and perform a few queries. So before we get started, let's see if we can do a pip install Sql Alchemy and just see if that's good enough. Yeah, it looks like I found it. Okay, so I have a file called Alchemy Models, and we're going to go ahead and do a very short, just a few lines, and see if we can get this to work. So I'm going to say from Sql Alchemy .ext.declarative, we want to import the declarative base. And then we're also going to say from Sql Alchemy, we want to import the following: column, integer, string, a foreign key, and create engine. And then that should be that. And then lastly, we're going to do from Sql Alchemy .orm import relationship. And that's it. So we import some functions and types. So the first thing we need to do is create an engine. The engine tells Sql Alchemy about the type of database you've chosen in this example, and then how to connect to it. So now we can make an engine. So we'll go engine equals create engine. And we're just going to say we want to use SQLite : / memory : So that's our database engine. And the base is going to be declarative base. All right, so now we have an engine. So now let's make a class person, which will take a base, big B base. And in here, we're going to make a table name, and we're going to call it person. Okay, and in here, we're going to have ID equals a column, which will be an integer, and have a primary underscore key. So we'll put that as true. And then we're going to have a name, which will be a column. And in that column, we're going to have a string. And we'll have age, which will be another column, which will be an integer. And SQL Alchemy knows how to handle these things to make that happen underneath the hood. So then we need addresses, and we're going to make a relationship. And in this relationship, we're going to need a couple values. We'll have, of course, address, and then we want back populates equals person, and we're going to order by. What do we want to order by? Let's do address.email, and then we will cascade all, delete orphan. Don't worry about this right now if you don't know what that means. And then we need to define REPR with self, and all we're going to do is say return f self.name, and ID will equal self.id. This should be in front of this. There we go. Yep, and then we need an address class. So we'll say class address, we'll pass a base. Again, we're going to make a table name equal to address. And then in here, we're going to need an ID, which will be column. And in that column, we will have an integer and a primary key, primary underscore key. So we want to set that to true. And then we're going to have email, which will be a column with a string. And we need a person underscore ID, which will be a column. And we'll use a foreign key, which is a key from another database. And we'll use person.id, which is the ID from the person database. Then we'll do person equals relationship, and we'll say person and back underscore populates equals addresses. All right, and then we just need to define str with self and return the self.email, and then have our REPR. So REPR will equal string class. All right, now we can just say base dot metadata dot create underscore all in the engine. All right, let me minimize this and let's talk through this for a second. All right, so each model inherits from the base table, which in this example simply consists of the default returned by declarative base. So we define person, which maps to a table called person and exposes the attributes ID, name, and age. We also declare a relationship with the address model by stating that accessing the addresses attribute will fetch all the entries in the address table that are related to the particular person instance we're dealing with. The cascade option affects how creation and deletion work, but it's more of an advanced concept. So like I said, we're not going to go over that right now. You can look it up if you want to. The last thing we declare is the REPR method, which provides us with the official string representation of an object, and it's supposed to be a representation that can be used to completely reconstruct the object, but we'll just simply use it to provide something in output. Python redirects the represent object to a call to like obj dot underscore underscore repr underscore underscore. So that's how it does that method. So we'll also declare the address model, which will contain email addresses and a reference to the person they belong to. And you can see the person ID and person attributes are both about setting a relation between the address and person instances. We also declared the string method on address and assigned an alias to it called representation, the REPR. This means that calling either representation or string on address objects will ultimately result in calling the string method. It's a pretty common technique in Python used to avoid duplicating the same code, so I went ahead and just did it that way. On the last line, we tell the engine to create tables in the database according to our models. So really all we did in these classes is the class is just we're defining the model of the data. Like, what does this look like? What does that Excel sheet look like, if you want to think of it that way? What are your columns? What are your rows? What kind of data is in there? Is it a text? Is it a number? Is it a string? Like stuff like that, So now that we have models, well, I guess it's worth noting you should probably go read up on relational database management systems, so RDBMS, SQL, relational algebra, all that stuff to really, really, really understand what's going on. But if you get the construct of that kind of abstract thinking through an explanation, then you should be fine. So now let's go ahead and persist some data. So what we need here is I have my models file. Now I'm going to have an Alchemy file. And in here, I'm going to say from Alchemy models, import person, address, and engine. Now I'm importing this from my file. This file. This isn't like a standard library. I'm importing this from that file. And then we're going to say from Sql Alchemy .orm, we're going to import session maker. Right, making some sessions. So now we just need to make one. So session equals session maker, and we'll just say bind equals engine, and then little session equals big session, and we'll just call that. Okay, so we created the session, which is the object we use to manage the database, and then we need to make two people, right? So we'll make two people. So we need Anakin, which will be the person, which we imported. Name equals Anakin Skywalker, and the age we'll put 32, and then we'll make an OB1, which will use the person class, and we'll set name is OB1 Kenobi, and age will be 40. I'm 40. That makes me feel really old. So now we need to add email addresses. So we could say ob1.addresses equals, and then let's say address, and we'll set email equals ob1 at example.com, and then we'll set a second one. It says address is email equals wanwan at example.com. And there we go. So now we can do Anakin.addresses.append address email equals Annie at example.com. And then we could do an Anakin.addresses. I need to spell this correctly. Append address. There we go. Address with an email equal to evil.dart at example.com. And then we'll make one more, Anakin.addresses.append. Hey, append address. We need email equals, dude has a lot of emails, Vader at example.com. And yeah, so we shouldn't really have touched the database yet. It's only when we use the session object that something actually happens. So now I can say session.add Anakin, and I can say session.add ob1, and then session.commit, and that will actually write it. Okay, so we add the two people, the person instances, and their addresses, because we use the cascading effect. That's what the cascading does. And then we call commit, which actually tells Sql Alchemy to commit the transaction and save the data in the database. So in this case, it's worth noting, a transaction is an operation that provides something like a sandbox, but in a database context. So as long as the transaction hasn't been committed, you can roll back any modification you've done to a database. And by doing so, you can revert to the state we were in before starting the transaction itself. Sql Alchemy offers more complex and granular ways to deal with transactions, which you can study in the official documentation because it's pretty advanced. But for now, we're going to query all the people whose names start with OB using like, which looks like a like operator in SQL. So yeah, and if you wanted to do that, you could do something like, ob1 equals session dot query, and then person dot filter, and then give it a filter. And so for the filter in this case, we could say person dot name, and then I told you we would use like, and then we'll just say ob, like that. And then dot first, and then we could say print ob1 comma ob1 dot addresses, and that should give you that. And then you could also print Anakin and Anakin dot addresses, boop, like that. And that would give you Anakin's ID. You could delete the object. So to delete an object like that, you could do like Anakin underscore ID equals Anakin.id, and then just say del Anakin. And the reason you do that is you want to see how to fetch an object by its ID. So before you do that, you'd write the like display info function, and you could use that to display the full content of the database, starting from the address, kind of in order to demonstrate how fetching works. So like if you wanted to see that, it would be like you make a function, be like define display info, and then just say addresses equals session dot query address dot just give me everything all. Why do I have query? And this should be in parentheses. That way we don't have a bunch at the end like that. And then you could just do like for address in addresses, print f, whatever the address dot person dot name, and then you could curly bracket like this, and then address dot email. Yeah, that should work. And if you wanted to display like how many objects you have in total, you could do like a print people open and close brackets, and then addresses open and close brackets, and then just say dot format, and then you don't pass it a format. So the format in this case could be like session dot query, and then grab person, and then maybe you'll do like a count, and then you could do like session dot query the address table and do another count, something like that. So the display info function prints all of the addresses along with the respective person's name at the end, produces a final piece of information regarding the number of objects in the database, and you can call the function and fetch and delete Anakin and display the info again to verify it actually disappeared from the database. And you can do that too with like, oops, let's put that back. You can do like display info and just call it, right? Now that we created it. And then in here, I could say Anakin equals session dot query person, and then I want to get Anakin underscore ID. And then I could do session dot delete Anakin and kin, and then the session dot commit and do the commit as well. And if you did the display info after that, you should see that it's gone. So if you run everything together, it's going to be kind of crazy. But go ahead and run it. I bet you we're going to run into like 9,000 problems. What is this? This is not closed address, like that one. You can see I'm running out of, my linter is very unhappy with the session. So yeah, you can try it and see what happens. I'll run it here, and I bet you I'm going to get a ton of errors. All right, so let's see. Instead of just looking at it, let's see if we can fix it ourselves. Okay, so first thing we need to do is spell filter correctly on line 23. So line 23, here we go, and go dot filter. I don't think there's an underscore there, or I don't think that there should be an underscore there at least. Correct me if I'm wrong, but I think that'll work. Let me see here. No, that should be right. Okay, so let's try it again. Let's find the next error. Can't load plugin Sql Alchemy dialects SQLite. All right, is there two L's in it? Did I mess that up? Let's see here. So that happened online. Ooh, look at that. No such module. Registry, create engine, entry point, warned, create engine, some engine problems. So first let's look at this load plugin problem. And I'm going to do a find for the word light. And I don't see where, oh, is that coming in from here? Oh, yeah, there it is, from SQLite. So in this one, that's my engine. Yeah, there's only one L in that, that's why. So let's save that, come back here, save this, clear the screen, run the script again. All right, we got rid of some more stuff. Unexpected keyword argument cascade in the relationship is a type error. So it's a type error, and we can see line 17 in person addresses. So here, Anakin.addresses.append address email Line 17. Oh, it's in my model. All right, so let's go over here. Addresses, relationship, and I gave it this cascade, which it really did not like. Cascade. Oh, it's because I spelled it wrong. Boop. All right, maybe that'll solve that problem. Solving problems. Okay, type error. Function. Argument code must be code, not string. Okay, this is in the file Alchemy models. In the person class person base on line 10. So on line 10 here. Okay, and then we see something about the function argument code must be code, not string. All right, so let's take a look here. So I have a person base, and then a table name is person. My ID, column, integer, primary key, name, blah, 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 column, integer, addresses, relationship. Okay, so I get to relationship, and I have a string. I have back populates as a person, order by is an email address, cascade, all comma, delete orphan. That should be correct. And then define address, let's see, representation, REPR, that should be R, self. Yep, so I changed that one thing. And I'm not sure exactly where it doesn't like this. In line 1, it's getting mad about this. And if I go up to line 1 here, I'm just saying, hey, import this, this, and this. So it's definitely, this definitely isn't the error. That's just where I imported it from. The error was here on line 10 with this class person base. The function argument code must be code, not string. All right, so let me try this. I only changed one thing, and it probably didn't fix the problem, but we wanted to just double check. Okay. All right, so do you see how much troubleshooting and debugging goes into building something? It can be quite a pain in the butt. All right, so let's look at this. The type error function argument code must be code, not string. All right, well, what the heck is code? I don't remember typing code anywhere because I didn't type code anywhere. So why is it doing that? Why is it doing that? So we have a type error somewhere, and it looks like it's in my class, my person class. And if I go back and look at the code one more time, I have a class person that takes an argument base, and I create a table name that's person. I have an ID, which is a column that takes an integer, and a primary key is set to true. The name is a column, which is set to a string. The age is a column set to integer. Addresses equals a relationship, and make sure I did spell this correctly, relationship. And in there, I just have address as a plain string, and then separated by a comma, I have back populates as equals person. I have order by is set to address.email, and I have cascade equal to all and delete orphan. And then I close it, and then I define the representation with self, and I return f self name, and then the ID is equal to self.id, and that looks fine. So I don't see any issue there. Did I not save it like this? Save. Let me try it again. All right, let me Google it. I'm gonna pause the video. Okay, so I found another bug to put into this, and mostly the reason for that is because the call to a meta class base function is where I'm getting the problem. So this may be an update to Python in the current version, which I just installed of Sql Alchemy. So what I'll do is I'm going to leave this where it is because the logic of this is sound, but I still have an error with this type error that's not going to go away. So what we're going to do is I'm going to keep moving forward, and then eventually what we're going to do is you're not going to be using SQL Alchemy anyways. We're going to be using real databases. So rather than waste time on this, we will move on and we will go to working with a real database. So anyways, that is everything you need to know about databases and writing to databases. Unfortunately, I couldn't get this type error to work, but you know what? It is what it is, and I'm going to keep going. So if you have any questions, let me know. But in the future videos, as we get deeper into this, we'll be using real databases, and then you can see what this actually looks like without using a virtual in-memory database.